vector of seas coming in and seas going out is itself hundreds of millions of years.
Each sea deposited different types of material that hardened to become solid rock. Some sediment was sand that became buff-colored sandstone. Some was mud that hardened into darker shale, while the calcified remains of marine organisms were crushed into light-colored limestone. And yet, the dominant color is red. That comes from iron, locked within all the rocks. Over millions of years, the iron rusts into a distinctive red hue. For the geology detectives, descending into the Grand Canyon is like traveling back in time. The calcium content inside garnet gemstones reveals that nearly 2 billion years ago, mountains the size of Mount Everest stood where the Grand Canyon is now. Sea fossils exposed in the cliffs show that as late as 500 million years ago, the land was the muddy bottom of an ancient inland sea. The next puzzle for geologists is uncovering which awesome forces transformed that unremarkable flat land into this breathtaking natural wonder of the world. From 1.7 billion years ago to 70 million years ago, the landscape of western Arizona has undergone a series of extraordinary changes. Ancient mountains have given way to prehistoric seas, which have withdrawn to reveal a low-lying flat plain stretching as far as the eye can see. The magnificent gorge of the Grand Canyon does not yet exist. But over the next 20 million years, this landscape was to undergo immense changes that would create a unique high plateau and set the scene for the formation of the canyon. Ancient fossils of sea animals tell geologists that this land was once under the waves of an inland ocean. But that leads to yet another mystery. The investigation needs to figure out why these undersea rocks are now high in the air, thousands of feet above sea level.
It's surprising to go up a mile above sea level and you find a clamshell or what looks like a clamshell. And you say, that's what I see when I go down to the ocean. So why is it here a mile above sea level?
It's clear that this region underwent a type of geological disturbance that pushed up the entire seabed. Geologists discovered in the 1960s that collisions between separate plates of the Earth's crust could force land up into the air. It happens all over the globe and usually deforms the land into tilted mountain ranges. But this Arizona uplift was unique.
After all the flat layers are deposited at sea level, there was a major uplift event called the Laramide orogeny, which lifted these rocks without tilting them, still flat, lifted them up to high elevation.
Because the land rose straight up, like being in an elevator, it formed a high, smooth plateau. The sea that had been there drained back toward the northeast. But as of yet, there was no Grand Canyon. The Colorado River, the force that cut the canyon from the rock, had yet to arrive.
Geologists from the very early days, from the late 1800s, are quite comfortable with the knowledge that the Colorado River has carved the Grand Canyon.
The high plateau was surrounded by even higher mountain ranges. New rivers began flowing from the mountains out across the plateau. It's essential for the investigation to establish when the Colorado River in particular arrived, because only then could it begin to carve the canyon. Until a few decades ago, some investigators thought this ancient riverbed, called Hindu Canyon, provided the answer. They believed that Hindu Canyon's creation, 50 million years ago, marked the arrival of the Colorado River and the beginnings of the Grand Canyon. But in 1969, the discovery of these pebbles turned everything that geologists thought they knew about the canyon on its head.
It turns out that to explain how the Grand Canyon got there is very much more complex than people thought. So the early geologists thought it was simple, but now we realize there's a lot more to the story, and it's kind of a detective story. You start out with a few clues, and you put the clues together, and then finally you get the satisfaction of saying, well, you know, I figured this out before anybody else did.
Figuring it out before anyone else was just what Young did in 1969, when he was a 24-year-old geology graduate student at Washington University. His professors sent him to investigate Hindu Canyon. But when Young arrived at the dusty riverbed, he discovered that it had nothing to do with the Colorado or the Grand Canyon itself. His discovery flew in the face of all the established geological theories and revolutionized thinking about the canyon's history. The evidence Young had uncovered was the alignment of pebbles in the bed of the river.
If you look at these pebbles, you can see that the pebbles are flowing, or the pebbles are oriented in this direction, which is a stable direction for water flowing to my right. If the pebbles had been oriented this way, the water would have flipped them over. So when we find pebbles that are oriented this way, that tells us that the water was flowing to my right.
It is a crucial clue. The Colorado River could never have flowed to Young's right. It has always run in the opposite direction, towards the Pacific Ocean. The river here, 50 million years ago, was not the Colorado, and it did not cut the Grand Canyon. Young's findings meant scientists had to rethink all their ideas about when the Colorado had arrived on the plateau and about the age of the canyon. They started examining evidence from another, less ancient site. This is Muddy Creek, near Lake Mead, Arizona, just a few miles downstream from where the Colorado River exits the Grand Canyon today. The underlying rocks prove that this was once the site of a vast freshwater lake.
The upper part of the Muddy Creek Formation is this nice limestone which formed in a freshwater lake. The water would have been very clean. There would have been lots of plants and animals living in the water, and as they sank to the bottom, the calcium carbonate in their shells would form this limestone, which is typically what forms a limestone rock.
The limestone is the calcified remains of the creatures that once lived in this lake. Then, 5.5 million years ago, the animals all disappeared. There were no shells to make fresh limestone. The only explanation is that the animals died 5.5 million years ago because that was the date when the Colorado River arrived here. The river would have been carrying masses of dirt and rock sediment from the fledgling Grand Canyon.
The water would have been too muddy and dirty, and limestone does not form in dirty, silty, muddy water. It's just incompatible. The animals and plants that live in such a lake can't exist if there's a lot of silt and mud in the water.
So, the muddy death of the lake gave geologists a confirmed date for when the Colorado arrived in Arizona and commenced its excavations. The Grand Canyon was born a mere 5.5 million years ago. The investigation has reached a significant milestone. It has discovered the age of the canyon. The angles at which pebbles lie in ancient riverbeds reveal that the Grand Canyon is far younger than geologists had previously ever suspected. The limestone discovered at Muddy Creek reveals the date that the Colorado River arrived on the plateau and the true age of the canyon, 5.5 million years old.